Hello guys, welcome back to Math Zone African Motives, still on our A-level mathematics, and here we're going to focus on the reduction, the linear law, whereby we have to reduce a certain function into a linear function. All right, like the question that you're given here, we are going to consider it and see how you're supposed to attempt such typical questions. All right, we are given that the table below shows values of two quantities which are given P and Q connected by the equation. All right, so this here is an equation which is connecting what? P and Q. All right, so I want us to take a closer look into this equation that we're given. We are given that P is equal to A plus B e to the exponent of negative Q. Okay, this is what we are supposed to have. And this is the table here that is representing the values of Q and P. All right, because these are the ones that are connected, the variables that we are talking about, it's P and Q. All right, so what does it mean? It means A and B are constants to be found. All right, these are constants to be found. That's why we are given here by means of a suitable graph. Find the values of A and B. So A and B are constants to be found, right? A and B are constants to be found. So what are we trying to say in this case? We are supposed to reduce this into a linear function. What is a linear function, or how do we present a linear function? All right, we know that a linear function is supposed to be in the form of y is equal to mx plus c. This is the format that we are used to on a linear function, where on this presentation that we are going to have a straight line that is being drawn on the Cartesian plane, talking of the x and y, and we're going to have what? A straight line. All right, whether it is of this nature or it is of this nature or this nature, what we know is that we are going to have a straight line drawn from this format of a linear function. So you are supposed to have the same format from this one to be presented in a linear way, where we know that this m represents what? The gradient. So we know that the m from our O-level mathematics is the gradient, and c is what? Is the y-intercept. So what does it mean? It means we are supposed to rewrite this in this format. Okay? In that format. So meaning to say here, if we are to check properly, because we say the P and the Q, these are the variables that we are referring to. All right? So meaning to say if this E is being raised to the exponent of Q, it becomes part of the variable. Remember, we cannot determine the value of X or the value of Y. These are variables. We can have the value of M, just like y is equal to 2x plus 3. Remember from our O-level mathematics, we had equations like this. In the same sense like this, we can have our equation maybe here, P is equal to, just going to write in terms of P, the way that we're given here, P is equal to, maybe our A is 2, just like this part, or 3, whatever that you have. Maybe this is 3 plus 2e to the exponent of minus q, because this is affected by a variable. It means there is nothing that you're going to find here. So this is a constant. This is a constant, just this A and B that we have. So these are constants. So if we are to take a closer look in the presentation of this in the same manner of y is equal to mx plus c, we are going to see that this is the part of x, this one. The b e to the exponent of q. This is the part that is representing what? This x. And this p is this part of y here. All right? So you can write this in that same format as P representing y is equal to mx, a number which is multiplying what? A variable, because x is a variable and the variable is on what? On q. Remember, we said q is the variable, so it's going to be b e to the exponent of negative q like this, plus a. So we have in the format of y is equal to mx plus c. So if we have this format, what does it mean? It means that this b here, just like p, is same as what? Is same as y. So it means on our graph, this y-axis here is now represented by what? By p. Just like y is equal to, now it's p is equal to. So the y-axis is now represented by what? The p-axis. All right? This is mx, the gradient times m, meaning to say x. That's why we have what? X here. But now we no longer have x. We've got what? E to the exponent of minus q, the part that has got what? The variable. The part that has got q. So we are going to have e to the exponent of minus q. So meaning to say this graph that we are going to have to be written or to be taken as a linear function, it means that we are going to draw the graph of what? Of p for the y-axis versus what? E to the exponent of minus q in the x-axis. Right? So we are going to have the graph drawn for p versus what? E to the exponent of minus q in the x, just like y is equal to mx plus c, just like y, just like this. So it's going to be p versus q, p versus e to the exponent of minus q. Okay? So meaning to say the m, which is the number affecting our variable, which is our m, here is what? It's b. So b is representing m. So therefore our b is equal to what? To m. And what is m representing? I said m represents what? The gradient. So meaning to say the gradient that we are going to obtain from that straight line is the value of what? Is the value of b. And we know that the gradient simply represents what? The change in y over the change in x. All right, what about a? Because it's another constant to be found. A is going to represent what? C in this case, which is our y-intercept. So A is the same as the C, and that is our y-intercept, where the graph crosses the y-axis, where the graph passes, where the graph has got an intercept with what? With the y-axis. That is your y-intercept. So that will be the value of A. If the graph drawn is for p versus what? E to the exponent of minus q, to make it to be, or to look like a straight line, to be a linear function. That is the linear law. So meaning to say this table here is not going to work, because this table was for what? Q versus p. But take note what we want this time. We want e to the exponent of minus q and what? And p. This is what we want on the graph, not q. So meaning to say we are going to have a table drawn in this case of the graph that we want, because like I said, we are going to have what? E to the exponent of minus what? E to the exponent of minus q versus what? Versus p. That is for the x versus what? The y. So meaning to say we need what is for e to the exponent of what? Minus q. Just gonna have a small table here. All right, just something of this nature. Okay, guys. I'm just gonna draw what you can see, because these lines, guys, they are difficult to have. All right. Anyways, this is it. So on this, instead of having the q that we had, the x, which it was represented by what? By q. We are now having as e to the exponent of what? Negative q. Take note there. Take note there. Okay? So meaning to say for the first value, it's e to the exponent of minus of this value, which is already what? A negative. All right. Let us bring the calculator. Let me explain this. So you're going to have the first value, e to the exponent of minus q. So this is e, shift e to the exponent of a negative. It's already a negative there. But the q that we have here is carrying what? A negative. So it's going to be a negative again. So that's a negative 2,485, like this. Okay, so this will give us something like what? Let's see the value 12,00 like that. So this is approximately what? Approximately 12. All right, so we're going to take this value approximately to what? To 12. Okay, so this is what you're gonna have for the first value. For E, remember we said these are values of what? E to the exponent of minus Q versus what? The P that we have for the y-axis, there's P. So the first value, we got a 12 approximately. That's a 12 there. All right. We move on to the other value. The second one, as it is on our table here, the next value is minus 2,303. So meaning to say we are going to have the same thing on our calculator. This is going to be minus. We move on. We're just going to change this. That's already a negative. That's 2,303. All right, that's 303 like this. Okay, and that is going to give us 10,00. So it's an approximate, which is what? Which is approximately a 10. So meaning to say the following value is going to be what? Is going to be a 10. So this is only affecting for this part of Q, where we've got e to the exponent of. So it's going to be a 10. All right, so that is what you're going to do for all the values up to the last one. So if we check here, we have got the next value, which is at -1, you put the value as it is, you're going to have an approximate 6,00 and so on, which is what? Which is a 6. All right, so the next value here was going to give you a 6. All right, so this was going to give you a 6. We move on to the next value at minus 1,386. You're going to get something like 3,9988, which is approximating to what? To a 4, to the nearest one number. That's going to be a 4. Okay, we move on to the next value at negative 0,693. If we put up this value, we're going to get something like 1,997, which is approximating to what? To 2 as a whole number. All right, so these are all the values that we are given. Now, as you can see, our table has changed because of what we have on our graph. Okay, what we have on the graph is the one that is determining now. That is the idea of the question. So like I said, on the graph, we are supposed to have this, the graph of what? E to the exponent of minus Q for the x-axis. Then in the y-axis, it's P. Meaning to say, P was not affected for the values of y. It was the x here, it was the x here that was affected to what? E to the exponent of minus Q. But y, which is represented by Q, is not affected. Meaning to say, the values of Q, they are not going to change. They are going to remain as they are, these values of Q. They are not affected. Q is not touched, it's not affected. If it was lean P like that, it means this was going to be lean P. It was going to be affected, but yet it's just P. So P is representing Y, so it's just going to be P as it is. So these values are going to remain as it 0, 1, 2, 3, up to 5. All right, so these values are going to remain as they are. That's 0, 1, 2, 3, 4. Okay. Seems like there's a value that I'm left here, 0, 1. All right, it's 1, 3, 4, 5. Sorry, 1, 3, 4, 5 there. Okay, 1, 3, 4, 5. I'm now like, what is happening here? 1, 3, 4, 5, like that. Okay. So that is the table that you are now having. Just like the normal table that you are used if you are drawing a straight line from your O-level mathematics. If this is X, if this is Y, how do you draw? You just need to mark your points, isn't it? For the X and Y. But this time it's no longer X and Y, guys. It's E to the exponent of minus Q. All right, so here I'm just going to have a sketch, but you're supposed to have a proper graph. If I'm saying a proper graph, it must be proper, all right, according to the scale and also the units and the values taken properly or accordingly. All right, your values taken properly or accordingly. So this is what we're going to have here for the x-axis. Like I said, we no longer have x-axis. We now have what? E to the exponent of minus q for the x-axis. Then the y-axis is represented by what? By p. So you're just marking your values according to scale. Maybe use 2, 4, 6, 8, or whatever that you have. All right. So that is, you are going to take your values like that. Okay. As you can see, for e to the exponent of minus q, they are up to the highest values at 12. So you can use the scale of 2, 4, 6 in the x-axis, all right, which is e to the exponent of minus q. So you're gonna maybe use 2, 4, 6, 8, 10, 12, 14. It's enough because the maximum value there is what? It's a 12. Then for the y-axis, which is for the p-axis, the highest value there is a what? It's a 5. So you can even use a scale of 1, 2, and so on. So you can just even use 1, 2, 3, 4, 5, and so on. All right. So you mark your points properly. Properly mark your points. Okay. So this is it. 12 versus what? 0. This is the same way that you mark your points, isn't it? From your O-level mathematics. 12 versus 0. And this is the point. 12 versus 0 here. 12 versus 0 on this one. 10 versus what? 1. So 10 versus 1, maybe somewhere here. It's according to you guys. 6 and 3, maybe somewhere there. 4 and 4. 4 and 4, maybe it's somewhere here. Then 2 and 5. 2 and 5, maybe somewhere there. Okay, so this is what was going to happen if you join. You are going to have a straight line. All right. Remember, if you place your ruler and you're drawing a straight line, definitely you can even extend your points. What am I trying to say? You can even extend this side. By extending, you will see where this line passes or crosses the y-axis. Why do we need this point? Because it is the one that represents the y-intercept. And we said the y-intercept represents what here? The y-intercept is representing A. So to find A is to know the y-intercept. Simple. We just need the value. We just need the y-intercept there. We just need the y-intercept there. All right. So if you are to draw this properly according to scale, you are going to see that this value was going to pass at the point 6. That was our y-intercept there. So if the y-intercept is equal to 6, therefore it means our A is also equal to 6 because A represents what? It represents the y-intercept. What about B? Because we also need to find the value of B. B, we said, is equal to M. And M represents what? The gradient. So in order for us to have the value of M, we simply have to find the gradient of this line. So to find the gradient of this line, we can simply use the points here, change in Y over the change in X. Isn't it, guys? That is what we know. The change in Y over the change in X. Since we know that this point is 6 here, the change in Y as we are going down, it's a negative. So that's negative 6. Over the change in X as we are going to the X, we're going to do what? Positive 12. So meaning to say M, which is represented by what? By B, which we said is the gradient. The change in Y over the change in X, that will be B is equal to Y as it is going down. It's a negative 6 over 12. So this is going to give us negative what? Half. So this is the value of B. Or we can use points. Okay? We can take points into consideration. What am I trying to say? Okay, this is it. Remember, we have got our points here, just like our normal graph of for the X and Y, right? If this is the X here, and this is Y, you are going to take a point like this, 2, 5. It's a point. X is 2, Y is 5. Okay? You move on to the point 4, 4. X is 4 there. Y is what? Y is 4. How do you find the gradient from? Because these same points are the ones that you use to draw this line. So meaning to say from the same points, I can determine the gradient. Okay? Because we know that the gradient is the change in Y over the change in X. X1, Y1, X2, Y2. So B, which is equal to the gradient, the change in Y over the change in X, that is Y1 minus Y2 over X1 minus X2. is going to be y1, which is 5, minus y2. In this case, what is the value of y2? That's a 4 over x1, which is 2 in this case. The value that we have is 2, minus x2, which is what? Which is a 4. So if we subtract properly, what are you going to get? 5 minus 4, that is equal to 1 over 2 minus 4, that is minus 2, which is same as minus 1 over 2, which is the same as the one that we just got by just looking into the graph and applying the formula, the change in y over the change in x. But as you know that b is the gradient, so you can have the gradient from what? From the points. You can even use the points to determine what? Your gradient. Just like that. Just like that. So that is the idea of the question. So meaning to say, this relationship that we see that made us to draw this graph can be written as, because we have the value of A and also, the value of A and P. So it means, therefore, here it was simply P is equal to the value of A. What was the value of A? Remember, we got A as 6. So it's simply 6 plus B. B was minus half. So it's simply minus half e to the exponent of minus q. This is the law that connects P and Q. That can be given as a linear function when written or when given as a what? As a linear function. So this is how the questions are given. We just hope when I have more questions of this nature and other topics actually, as we are revising, let us also try to revise our basics by checking other classes. You can check for other netted classes, N1, N2, N3, up to N6. The basics that are part of your syllabus, right? In terms of any simplification, is it the logarithms? Is it the derivatives? Is it integration? All right. Completing of the square, whatever that you have in your syllabus and is related to another course, just watch those videos. It can help you to have basics of understanding. As we are moving together, we shall try to have more question papers and also introductions of some certain areas to prepare ourselves for the exams that are ahead of time.